going to be a quick BC3300 system overview. This is page number 32 of the user's manual. They give you this kind of a crude block diagram. It kind of gets the point across. We don't have schematics for this. If anybody has a schematic for these battery chargers, let me know because I'd be really interested. But, well, let's get started here. So in the previous video I showed the input comes in through here. Comes in through that orange cable into here. That then goes through these two fuses right here, or these two. Then we go into, this is your Inrush current limiter. It's positive temperature coefficient thermistor with this relay which bypasses it. So this is your, keeps it from sparking when you plug it in. And this is the Inrush limiter right here, and then right next to that is that relay. Then we have these two caps down here. That's these guys here. And then these two input filters are the big common mode chokes. And then in here are two varistors, and that's this and this. And then we have some assorted capacitance to ground for EMI reasons. That's pretty much everything. Yeah, that's everything with this on this board. This next section here are, well, let's go this way. We go into the power supply. So there's a bridge rectifier here. That's this board. This is the bridge rectifier right here. Some more filtering. And that gets us to the power supply converter, which is located on this board. That's this section right here. So we have a rectified DC, well, it's rectified AC, so you got the DC comes in through here, ends up on this on this cap here. This is the bulk cap through the fuse. Also another common mode choke. We go through. There's a this transformer right here. T6 is this guy right here, and then the inside here's all of this logic switch, and this little opto isolator is right here, so that that can regulate on the low voltage side. And then we end up with the rectifier and everything, and 12 volts out ends up going on this capacitor here, becomes a main 12 volt supply. And then this 5 volt regulator is this chip right here. It's an adjustable regulator. It's set for 5 volts. And then we go into the assorted relays and things like that. They're under, there's one buried underneath here for these guys, for that one and this one. And that's it for this board for now. We're going to come back to it later. Then we have the oh, I guess that was the system board with the microprocessor. This is the microprocessor board, and this whole section right here is what you plug in. That's this whole section here with the temperature sensors and your different enables and the LEDs and everything. And then let's see what's next. This pulse logic, oh, well, let's go this way. So I think I've gotten all this, yeah. Oh, the output here where it reads the battery voltage, that's also on here. That's this circuit. All of this right here is this part, voltage measurement. This isolator is located right here. And then, so coming in, so I think we left, I got this part. Oh, this section here is on the gate driver. They call it pulse logic in drivers. This measurement circuit and this isolator is right here. That's this section right in here. And then all this is the pulse logic and drivers, like it says. And then the two temperature sensors for the onboard temperature sensor go here. And if we move this over a little bit, so coming into the system here, we have, although it's not drawn on here, there's another bridge rectifier, and it actually consists of this diode, this diode, and then inside here there's another diode. Oops, I can't see that. There's another diode in here, and on the other side there's the same thing. There's another diode in here. So that's the bridge rectifier for the power stage. It's made up of 4 individual diodes. And then these switches here are located, this is one bank, this is another bank, and then these 2 switches are this guy, these 2 and these 2. And then, well, I've got this here on the back side. You see output rectifiers, and there's 8 diodes. These 4 diodes here are this rectifier, and then these 4 diodes here are this rectifier, and then these 2 output switches are these 2 guys right here. And then there's none on the inside. And then these transformers are, these are right here, they're potted. You can see there's one on each side. Alright, so I got all of that. Output filter is this board. So this is your main output filter, and then this is all bulk cap capacitance for going out through this fuse to your battery pack. And let's see, is that everything? Oh yeah, here's the battery fuse. And forgot this guy. So this is what usually dies on here. So the switches are down on this board, and then they come up through these capacitors right here are actually these guys, this group, and this group. And these little transformers here that are labeled pulse transformers, these 2 guys are these ones right here. And then this one right here is this little tiny one that's underneath here. It's a little tiny ferrite core, and it's got a little tiny pulse transformer right there. And then these are just filters and more bulk filtering. After it gets rectified, it goes onto these guys. This forms the bulk capacitance here. And what happens when you lose these capacitors, or these capacitors die, like this board has issues, and it's only putting out half power. If one of these caps die, they usually blow open, and when that happens, you can see there's no way to complete a circuit anymore, so you don't get any power transfer across there. And the same happens on here. If you lose one of these, you don't get as much power transfer. Now these things, when they typically die, you end up with either putting out 100% power, 75% power, 50% power, or 25% power, or 0. And the reason that happens is if you lose one of these caps but not the other, you still have a circuit. It can still transfer energy through here. This is a half bridge driven resonant converter. And if half of your capacitance is gone, because these are in parallel, if one of these is missing, then you end up with only half as much energy being transferred for every cycle. So what it does is it turns this guy on, then this guy on, then this guy on, then this guy on. It goes back and forth, 50% duty cycle. And by adjusting the frequency, it can transfer energy to the other side over here, and then this buck regulates it back down to run your battery pack. But it's fully isolated. It's actually a really nice design. It just has these caps. I mean, it lasted 20 years, so it does get its job done. I mean, this was probably, I don't know if there's a date. I mean, this says 95 on it right there, so it was at least engineered in, 20 years ago. It's 2015 today, right now. Yeah, actually, right here. So, February 20th, 1995. We're getting pretty close, because what is today? It's February. I think it's the 5th. So we're actually getting close to this actually being, or at least the design, 20 years old. Not sure when this one was actually built. But that gives you a brief overview of the system, how it all works, and hope that clears everything up. Thanks.